Everybody, welcome to Proficient Learning. I'm Akila Satyamurthy, physiotherapist specialized in cardiopulmonary sciences, and today's topic is biomechanics and kinesiology, the foundation of physiotherapy. Every structure in our body, especially the connective tissue, presents with a mechanical behavior which can be described in the form of stress, strain, failure, and stiffness. This response depends upon the magnitude or properties of the force as well as on the composition of the material or composition of the connective tissue. It is said that the deformation that happens is specific to an imposed demand, and I have listed some of the examples over here. Now, if this property is plotted on a graph, it gives rise to the most popular curve called as the load deformation curve, or the also known as the stress strain curve. This curve has four points and three regions. The region from 0 to A is called as the toe region, representing 2% of the curve, and this is the region where the slack is removed. This region tells that very less force is required for a deformation to occur, and a very good example of this is the tension that is built up in the tendon when a muscle contraction is about to occur. The region between A and B is the area under A and B is called as the elastic region, and over here this region of the curve, this is the only region on the curve that has a linear relationship with the stress. That is, as the load continues to apply, the deformation continues to happen. When a constant load is continued to apply, the deformation continues to happen. When this load is removed, the structures return to its original dimension, and in this property is called as hysteresis. This represents 4% on the load deformation curve, and a good example of this is the change that happens in the muscle when a contraction is about to occur. The area under B and C is called as the plastic region, where there are irreversible changes that are occurring to the load that is continued to apply. And if it reaches the point C, that is called as the point of ultimate failure, beyond which it is irreversible and beyond which there is complete tear. An example of the plastic region is grade 1 and grade 2 ligament sprain or tendon strain. And an example of point of ultimate failure is fracture, avulsion fractures, muscle tear, complete muscle tear. If you look at the properties of the mechanical properties of the bone, this bone, it depends, as we saw, that it depends upon the, apart from the properties of the force, it also depends upon the composition of the material. So the bone is made of two types. There is cortical bone and cancellous bone, where cortical is dense and it is firm, whereas a cancellous bone is more spongy and consists of the trabecular system that develops based on the load that is applied during static activities and during dynamic activities. Whatever load is there passes through the bone during weight bearing. The trabecular system develops along this line, and this gives the viscoelastic property of the nature, viscoelastic nature to the bone. That is, it allows the bone to be a little more malleable and a little more elastic when compared to a cortical bone. It is seen that the cortical bone is dense, stiff, and breaks very easily under a shear force, which means lesser shear force is required in order to reach, for the cortical bone to reach the point of ultimate failure on a graph. The property, the feature of this trabecular system developing along the line of forces is called as. This is an example of the trabecular system within the bone of femur. As you can see that the points of overlapping are the strong points in a bone, whereas there are regions where there is no trabecular system, and this is the point of weakness. As you can see, it is present at the neck of the femur, which is why neck of femur fractures are. Let's look at some examples. Cortical bone reach MCQ questions. Sorry. Cortical bone reaches a point of ultimate failure when the shear force or strain. So some of the or terms are shear force. It can also be called as strain, or they can specifically mention which kind of force. So cortical bone reaches point of ultimate failure when the force reaches 2, 4, 6, 10, and the answer is 4%, which means beyond which it enters into the point of ultimate failure. Point of ultimate failure on a bone in a decreasing order is as follows. That means decreasing means from more to less. That means which force is required, where in which order, that is so that means what they are asking is from more to less, which means you need, that is the meaning of decreasing, you need more force for the bone to reach the point of ultimate failure. So the answer, so as we saw, it is compressive forces. So there are only two options which has compression forces in the beginning. Okay, but as you can see, D has an equal to sign, and we very clearly know that it breaks very easily under shear force, and the response is not equivalent across the forces. So the answer is A. That means you need more compression force and you need less of shear force for the bone to reach the point of ultimate failure. The modulus of elasticity of a bone is lower for which of the forces, and the answer is compression force again, which means that it is more malleable under the compression force. So as we can see that all three examples all three questions were on compression forces on a bone, and which were asked in three different manners. So this is how we'll be dealing with MCQ questions. To learn more, please join the course and we shall be there to train you and guide you. Thank you.